Hi, this is Micah Frank. I'm an electronic music composer and sound designer. I also run a company called Pure Magnetic, where I make plugins, and it's also a music label. What we're looking at here is my live coding setup. I'm running C Sound for the audio processing and generative sequencing. And on the visual side of things, I'm running a program called Hydra. Both C Sound and Hydra are open source and free. Today I'm not going to go into Hydra so much. Instead I'm going to focus on C Sound, where I do most of my coding. I build plugins in C Sound, and I build small instruments and audio effect processors. C Sound was originally developed at MIT in 1985. So it's fairly old, but it has an active development community, so a lot of the functions and, well, the functionality stays pretty fresh. So just to start off, let me quit out of C Sound here. And let's move over to this application called Cabbage, which is where I do a lot of my coding and plugin development. The first thing I want to show you is an application I wrote called Beatfox. Beatfox is a free open source prototype. It's part of a series of prototypes that I've been releasing on my Instagram profile. You can also download it on GitHub, but there's a lot of interesting things there. There's a granular workstation. There's some interesting delay effects. There's some interesting modulation effects. I've mainly just been releasing these on my Instagram and GitHub just as small little projects. Basically, they're code that I'm working on for my own projects that I've encapsulated into smaller chunks, and I've created plugins from them. If you search on Instagram, #MFPrototypes, you should see all of the prototypes that I've developed so far. So Beatfox is an algorithmic beat machine. Has a bunch of parameters for synthesis that you can adjust. And it basically generates a sequence of patterns. So I can tell it how many patterns I want to generate. 10 is a good number. I can set the minimum BPM for each pattern, and what it's going to do is it's going to choose randomly between the minimum and the maximum. So let's say I want to have a minimum of 105, maximum of 130. And then for steps, this is how many, this is actually, it's on a 16th note grid. So this is how many 16th notes you want per pattern. So normally a Groovebox would have factors of 4, so 4, 8, 16, etc. But I really like odd patterns, so I'm going to put it at 17. And this is a small mixer section. You can mix it as you go, as it's generating the patterns. And I'd like to point out that all of the patterns that are created are actually written to a folder on your hard drive. So it doesn't generate the patterns for you to use in real time. It generates patterns for you to pull from your hard disk and use as loops within an application like Ableton Live or Logic. I'll show you the rest of that in a second. Density controls how dense or sparse the voice is. So density for bass drum, density for snare drum, density for hi-hats and percussion. All right, let's generate a few beats and see what's happening. Just gonna turn up the BPM a little here. right, so now let's open up Ableton Live. And find the beats that I generated. Perfectly looped. Looks good. All right, so back in here. I'm just going to show you a little bit about how Beatfox works, because it's basically the engine that runs my live coding setup as well. What happens is when a new voice is triggered, it generates a bunch of random values with constraints so that a voice can be generated. And I have different values based on the type of drum that's being generated. So for instance, this is going to determine the length of the kick drum. And so it's anywhere from 0.15 seconds to 1 second. Then the frequency, so it generates a frequency between 50 hertz and 80 hertz. So it is a little bit of determined randomness with constraints. The snare frequency also, for instance, has frequency ranges between 60 and 200 because I determined through trial and error that those were the ideal frequencies for the sustain portion of a snare drum. And there's some other hi-hats and percussion things that get generated as well. The most important part of Beatfox is the sequencer, though, and it's fairly simple. It's only a few lines of code, but it's very flexible too. What happens is a metronome is triggered based on the BPM that's selected, and then it just generates 16th notes, and for each 16th note it decides, is it going to insert a value or no? So it compares this decision against the density as well. So if the decision to insert it is greater than the density, then it's going to add more. If it's less than the density, then it's going to add fewer, so it'll be more sparse. And it does that for each voice. And then once it's done, it counts up all the 16th notes, and then it resets the whole thing. So all of the drum voices are resynthesized, and then also the sequencer starts over again, and it writes each one to disk. So yeah, pretty simple. Beatfox. Let's generate a few more beats here. You can generate really long beats also. So like 116 steps. And you can be sure that your beats are not going to be repetitive. Another cool thing I like to do, I don't think it's going to stop now. All right. Another cool thing I like to do is you can create some really cool overlapping rhythms by only bouncing a bass drum, for instance, and setting it to some number, say 19 steps. You bounce that out, and then you do the same with a snare drum. Maybe you do 26 steps and do the same with a hi-hat. Then once you go and import all of those tracks into live, you have some very complementary but very interesting juxtapositions of patterns overlapping one another. So it's a really interesting way to create complex patterns by bouncing out different voices with different step values. Okay, now let's go over to my live coding setup. And usually all my live coding work, my session for live coding is pretty much already written out, so I don't have to write everything from scratch, because in a live situation it's impossible for me to think about writing code from scratch. So what I tend to do is I have this setup, and then I usually just manipulate different values and move things around and it's all, the structure is basically there, so I don't have to worry about generating things from scratch. But let's generate something from scratch here just so you can see what's going on. And as I mentioned before, so the way I've created my live coding setup in C Sound is such that it creates 100 patterns per voice when the program is launched. So each pattern is different. I never know what the patterns are going to be. That's kind of the interesting part for me. It's completely algorithmically generated. And so each of these patterns is stored in an array. And I need to get the pattern number that I want to use. So this is all of the kick patterns are stored in an array called GI kick pat, and I choose which pattern I want to get. So I'm going to get pattern number 2, and that's going to go into this array that I've assigned called inum. I have a pattern here called play pat, and it's going to play then my kick instrument, and I'm going to use the inum array as the pattern. Okay, so I defined my kick pattern, and now what I need to do is I need to trigger it. So I'm going to trigger that with and I also have here, I have a parameter called GK step, which is basically 16th notes. So I'm going to assign how many 16th notes I want this pattern to be. And I'm going to say, let's make it 19 16th notes. Oh, and let me pull my C Sound window up here so I can debug if I need to, which I'm probably going to have to do. And now let's see what happens. Cool. I like that sound. Okay, so it played the pattern once. I want the pattern to repeat. So what I'm going to do is do something called temporal recursion, which basically tells the pattern to play itself once it's done. And this is all C Sound stuff that I'm not going to get into now, but it tells it basically to play the same duration starting at the next available time slot. So I'll reevaluate that. Oops. All right. And I'm going to copy this whole thing now and make some snares. For my snare, I'm going to make it 12 steps. Okay, so I'm not crazy about that snare sound. I have another function in here that will let me reset the snare sound, regenerate it. It's called snare set. No. Kind of like that one. Okay, I'll settle on that one for now. And I'm going to keep adding more voices. I have an instrument in here called blowout that basically makes a bunch of electronic-y, glitchy kind of sounds. Now what I have to do here is I tell it to play the pattern blowout, I tell it to play pattern 1, but then I also need to add another parameter to tell it that it's a melodic pattern. Well, it's not really melodic, but it's got frequency stuff in it. Otherwise it won't work. changing the hi-hat pattern to 20 steps. I'm going to see if I can make a different hi-hat sound, since this one seems sort of inaudible. So to make a new hi-hat sound, I need to run hat set. There we go. All right, cool. So I have sort of an interesting beat here now. Now what I want to do is I want to create a little more variation, and I have this function called sometimes, and sometimes is similar. If you ever use tidal cycles, it's sort of the same thing. Sometimes basically is a chance, sets a chance value and an outcome. So I can do something like this. I set a variable number to sometimes, and then there's going to be a 20% chance that it results in 2, and an 80% chance that it results in 5. So I can take that inum value and apply it to the pattern. So now it's going to switch patterns based on that value. So sometimes it's going to be pattern 2, sometimes it's going to be pattern 5. That's for the kick drum. And I can do the same for all of these now. So for the snare, I can make it a 40% chance that it plays pattern 8, and 60% chance that it plays pattern 2. So I can do that with all of these. Oh, but I got to remember to also put the value at the end of the pattern there. Otherwise it won't work. Cool. Let's see what's happening over in Hydra. So this is all of the graphic stuff. It's generally responding to different parameters that are being sent from C-Sound. All right, so that's my basic setup. That's what I'm using for live coding and composition and plugin development. C-Sound does everything. Thanks for watching. This is Micah Frank. You can catch me on Instagram, micah.frank.studio, Twitter, Micah Frank, micahfrank.com. All right.